In this video, we're going to take a look at the circle in which the radius is not 1. So in this circle here, we're going to go ahead and draw the same idea where we have a radius. Again, it's not a value of 1. Let's just call it r. If we establish the same triangle that we had seen in the previous video, we can also say that it has an angle theta starting at the 0-degree mark and working its way up. If we want to find the trig ratios, let's say cosine of theta. Remember that cosine is the same thing as adjacent over hypotenuse. In our triangle, again, because we don't know the length of these measurements, we are going along the horizontal x units, and we're going along the vertical y units, giving us the ordered pair x comma y. Well, in this case, cosine of theta, being adjacent over hypotenuse, will give us the ratio of x over r. Likewise, if we want to find sine of theta is opposite over hypotenuse, which is y over r. Notice that the only difference here between this circle and the unit circle is that we don't have a denominator of 1 anymore. It's a denominator of r, and that value could change. And then our last trig ratio, if we want to find tangent of theta, then tangent of theta is opposite over adjacent, which is going to be y over x. Over to the circle on the left side, what we're going to do is examine the different quadrants and how it could influence the trig ratios and its values. If you take a look, let's say if we examine the quadrant 1, I'm just going to focus on quadrant 1 here. If we're in quadrant 1, let's say that you have an arbitrary point right here, x comma y. What you'll notice is that in order to get to this point, you would have had to travel to the right and you would have had to travel up. Now, in terms of measurements along the coordinate plane of the x-axis and y-axis, you know that if you actually travel right, you have a positive value of a number. And if you travel up, you also have a positive value of a number, meaning that every single ordered pair that is contained within quadrant 1 will always have an ordered pair in which the x value is positive and also the y value is positive. So you have a positive comma positive ordered pair in this particular quadrant. Because you have positive values throughout this entire quadrant, what that leads us to see is that if you look at this triangle, you're always going to find that sine of theta is, well, as you can see in this ordered pair, is a positive value. Cosine of theta is also a positive value. And if tangent of theta is the same thing as sine theta over cosine theta, which we have just established is a positive value over positive value, that means that tangent of theta is also a positive value. So what we see here is that all trig ratios are positive in quadrant 1. In quadrant 1, all trig ratios are positive. As we take a look at quadrant 2, I'm going to focus on quadrant 2 now. Okay, so I'll do this in a different color. In quadrant 2, what you'll establish is that in order to get a triangle, the radius is going to come somewhere along this path here in the diagonal. And you can form any radius along this path here, but what you'll notice is that in order to get to any one of these points, you would have had to travel to the left, and then you would have had to travel up. Regardless of whatever point you choose here, you have to travel left and up. Well, if you go left and up, then what we know is that along the coordinate plane, every value that you go left, these are always going to be negative values. And every value that you go up is always going to be positive values. Okay? So what that leads us to see is that the ordered pair that we have established here is going to be in the form of some negative number and then some positive number for y. Okay, so negative will always be x and positive will always be y. Well, because we've established that any ordered pair in this quadrant will always be negative comma positive, then again, looking at our trig ratios, what we can see is that in terms of sine of theta, sine being the y value, we see that sine is a positive value. If we take a look at the cosine values in the triangle, we can see that the triangle is always going to be made up of adjacent over hypotenuse, and adjacent over hypotenuse is always going to give us a negative value. And then for our last trig ratio, because we're working with tangent of theta, remember that tangent of theta is the same thing as sine over cosine, And so if we establish the sine as positive and cosine as negative, we have positive over negative, giving us a total value that is negative for tangent. Okay, so what this shows us here is that if you take a look at the sine, only sine is positive, but everything else is negative. Okay, so we're just kind of establishing as we go through different quadrants what is positive and what is negative for our trig ratios. If we take a look at quadrant 3, do this in green. Again, we'll find some kind of arbitrary point here, and you're going to be able to build your triangle in this way, where now you're going to have your angle theta over here. Now, because you have established that you have a value here to get there, we would have had to classify this as the point negative x, comma, negative y. It would have had to go left along the x-axis and down along the y-axis. So we have a negative and negative value. Okay, so because we have a negative and negative value, instead of having the x and y, let me just call that a negative negative. Then what we will have established is that in getting these trig ratios, the sine being the y value again, is going to be negative. The cosine of theta is the x value, which is negative again. And if we do the tangent of this value here, tangent is sine over cosine, or that'll give us negative over negative, or that'll give us a positive value. So you see that anything in quadrant 3 is always going to be a value that is negative for sine, negative for cosine, and positive for tangent. So in quadrant 3, only tangent is positive. Okay. Sorry, I forgot to classify the second quadrant here. Second quadrant, we see that sine is positive. Okay. And then let's do one more. Let's do that last quadrant here. So in quadrant 4, you can establish any given triangle here, right? And then this is your angle theta. And with this right triangle here, we classify this as the point, well, in order to get here, we need to go positive along the x and negative along the y. So this ordered pair will be positive for the x and negative for the y. In establishing our trig ratio, sine is going to be a value that is negative. Cosine will be a value that is positive. And tangent of theta, which is sine over cosine, will give us a final value that is negative. So you'll see that in this quadrant, quadrant 4, the only value that is positive would actually be the cosine value right there. Okay, so in this particular quadrant, quadrant 4, only cosine is positive. Okay, so what I've tried to outline here is what you'll notice here is that every single time I was trying to find out what values were always positive. And so that's what I've established here. These are the values that are always positive values depending on which quadrant you're in. And I've tried to emphasize here, if I take the first letter of each of these, what you'll notice is you can actually develop a mnemonic to remember which trig ratios are positive and negative in those particular quadrants. And so if we go in order, going from quadrant 1, 2, 3, and 4, going counterclockwise, what we'll see is that we create the mnemonic A, S, T, C. Okay, A, S, T, C is a helpful way for you to remember which trig ratios are positive in which quadrants. And it just classifies it as quadrant 1, quadrant 2, quadrant 3, and quadrant 4, like that. Okay, and some people, different techniques have been used to memorize this mnemonic. The most popular mnemonic that students like to remember is that all students take calculus, right? Because A, S, T, C. But if that mnemonic doesn't work for you, you can make whatever mnemonic you like. In previous years, some students have given other mnemonics that help them memorize it. Some have said like a silly turtle cooks. You can make whatever you want, but the idea here is just remember the mnemonic ASTC, and that'll help you remember that depending on which quadrant you're in, your trig ratio will be positive or negative values.